That's how it is in the docs.
Yeah, I
was
meant
on
for the function declaration at the top of that file. Then at the bottom, yeah, I did module.exports
Yeah.
equals find Armstrong numbers.
So you're right. So another way we could do this, if we wanted to export something, is we could say function this, and then module.exports equals find Armstrong numbers. And then our arm here would just be the function, I believe. So I would be able to just do this.
Okay, I understand now. So it's either or. How
Mhm.
with the okay. Thank you.
Yeah, let me make sure I'm right about that. I've been wrong before. Yep. So when I do module.exports equals, then I'm just exporting the function as opposed to multiple functions, perhaps. And there's no right or wrong way to do these. You can do them in either way. It's just a matter of making sure you know which one you're getting when you export.
Thank you.
No problem. So I'm going to keep it like this. I'm going to call this just Armstrong. Expect Armstrong, like that. Cool. So let's write some more tests. So we have one right here that says that we handed 8, and it gives us all of the numbers up to 8. So I could say test returns multiple single-digit numbers. And we can just say expect Armstrong, passing in our create array of num with 8 as an argument. And we expect that to equal. And then we can just copy this here. And so, yeah, that's pretty much all it needs to be. And then we can just do the same thing for these. So test returns all Armstrong numbers below 99. We can say, oh, I spelled expect wrong up there. Got to be careful of that. Expect Armstrong, create array of num with 99, dot to equal, and this one time it's just an array of 0 through 10, or 0 through 9, I should say. And then finally, the last one that gives us everything up to 999. So test returns all Armstrong numbers below 999. Oh. And we expect Armstrong create array of num 999 dot to equal, and I'll just copy this array here, which has 0 through 9, and then 153, 370, 371, and 407.
No, I may have missed it, but the .2 equal compared to the .2b, what's the difference there again?
Let's say, so in the documentation here, so it says right here, dot to equal recursively checks every field of an object or an array. So dot to equal is better to use for data structures, while dot to b is more useful for if you just want to check if two things are equal normally. I think dot to b would probably work just as well as dot to equal in this case, because these are single dimension arrays. But for example, if you have an array within an array, dot to equal would work, but dot to b probably wouldn't.
Okay, thank you.
All right, any other questions about our test-driven development before we get into the code itself? Oh, there we go. All right, I'm going to just run my tests one more time to make sure all of these only fail because I'm not returning the right value. Yep, so I'm just getting a bunch of received undefines when we want to be getting arrays full of numbers. So it looks like our tests are working as we expect them to. Now that we've done that, we can actually start pseudo coding and then making our find Armstrong numbers. All right, so let's do some pseudo coding here. Make sure we're breaking this down into as small steps as we can. So I'm going to go over the requirements one more time, just so I know I'm getting them right. That's not it. Where's Armstrong numbers? So we want to be able to, in order to do this, we know that we're going to have to be able to take a number and break it down into its component digits so that we can get the exponent of each of them and then add them all up together, which is not something that JavaScript will normally let us do with an integer. You can't just say, give me the first digit, give me the second digit. So with that in mind, let's start breaking this down. So first off, okay, before we really worry about, okay, how do we do that? Let's just do our very first step. What should our very first step be? Because we know that we know from our tests that we're expecting to return an array, right?
Yeah. So we could declare an empty array variable.
Yeah. So declare an empty, we could even say like output array equals like that, because we know that's just what it's going to be. Okay, so now we have an empty array, and we know that our argument is going to be an array of numbers. So I'm going to put that there because I know I have to do that anyway. So what do we got to do with this array of numbers in order to do something to each number in it?
Iterate through the numbers?
Yep, we need to iterate through that number array. So iterate through numbers. All right, so that's the two first steps out of the way. We define an empty array for outputting, and then we have to start iterating through our numbers. So now we know, all right, we need to make sure that we can check every digit of a number. Since an integer doesn't allow us to do that normally, what can we do to that integer in order to allow us to do it?
We can convert it to a string.
Yeah. Convert number to string. Because when it's a string, we can check each and every character in it. All right, what comes next? Remember, don't worry about the math. Don't worry about the code thing. Just think about, okay, in plain English, what do we have to do to each digit in this string?
We got to break up the string into individual quote unquote characters.
Mm-hmm. Yeah, so we could break up the string into individual characters, and there are multiple ways to do that, right? We could convert that string into an array if we so choose. We can also iterate through that string as well, just like we would an array. So those are both valid options there. What do you all think?
I would iterate through.
Mm-hmm. So we can iterate through the number string. And so now we're looking at, say, for example, our number is 371. We get to 3, what do we want to do to it?
We're going to want to raise it to the power of the length of the string.
Mm-hmm. Yeah, so the length of the string. So first we need to find the length of the string before we even do that, right? So we can go back a bit and say, find length of string, and then raise character but to the power of length of string. All right. And then what do we do with it after we've done that? Because we're going to need to add all these up,
We're
right?
going to we're going to sum it.
Mm-hmm. So we're going to sum it. So it means we need to add it, but what are we adding it to?
We could create another variable equal to 0 and call it sum and just add.
Yeah. So we can say define sum, which equals 0. and then add to sum. So we're adding each of these multiplied numbers to our sum. And so when we get through the entire number, we should have the grand total of all of them, right?
Noah,
Yes.
I think I'm missing something. So you're going to create a string here with each of these numbers. Let's say it's a string of 3, 7, and 1.
Yes.
And you're going to iterate through that. And you're going to raise each character that the computer thinks is a letter, basically, to a mathematical power. How does that work?
Well noticed. So that's probably not going to work, right? Because we've seen before that JavaScript doesn't like it when you try to do math to a number, to a string, excuse me. So what can we do to these characters to make sure that we don't get an error?
Change it back into an integer.
Yeah. So convert character to integer, then raise to the power of length of string. Oops. Then. Well noticed. All right. Now, so at the end of this iteration, this one, we should have all of all of those digits raised to the power of the length of the string added together. Then what do we need to check?
We need to check if that sum is equal to the number we were breaking up.
Yep. So if sum is equal to the original number, what do we do?
Push it onto the output.
Yeah. Append to output array. And then at the end of this large loop, what do we do next? Should be the last thing we do.
Return the array.
Yeah, we return output array.
Output array, yeah.
All right. So how does the pseudocode look to everybody? Does it make sense? Because everybody's got a different pseudocoding style, and so if mine isn't really jiving with you, I'd like to know so we can define anything before we really start grading our code. Okay. In that case, I'm going to start turning our pseudocode into actual code. So first step, let output array equal an empty array. Next, we need to iterate through the numbers. So I'll say for let I equal 0, I is less than numbers dot length, I plus plus. So we're iterating through the numbers, and we can need to convert that number to a string. So we could say let number string equal numbers I dot to string. Next, we need to find the length of the string. So let string length equal number string dot length. Then we need to define a variable called sum, which is equal to 0. Let sum equal 0. Then we iterate through the number string.
No, why is it that like you have numbers sub I dot toString and you have to invoke the function brackets on the end of the toString, but on dot length you do not have to invoke the brackets?
So dot to string is a function, and a function won't be called unless you use the parentheses. Length is not considered to be a function. Length is considered to be a property.
Oh,
so
okay.
it's something that a string holds on to automatically, so it doesn't need to invoke a function in order to calculate it.
So a string is an object and it has a dot length property.
Essentially.
Okay.
Yeah. When you get, if you like take apart the string data type in JavaScript, you'll find certain things are built in functions and certain things are built in properties.
Okay.
But in Python, it's considered like a function, right? The length.
Python has a function to calculate length instead of having every string just hold on to that like that in that way. Good question. All right, next we need to iterate through our number string. We can call this C equals 0. C is less than, you can even say string length here. C++, name of a language, little joke there. And we need to convert each character to an integer. So we could say let integer equal parse int, number string C. And then we need to convert the character to an integer. We did that, then raise that to the power of the length of the string. So we could say let exponent, if I can remember how to spell exponent, equal integer to the power of string length. And then we could say sum plus equals exponent. All right. Is that any questions about, what questions do you have about what we've done so far? Okay. So next I'm going to say if sum is equal to number, then we say output array dot append our number.
Is append for Python, or does that work in JavaScript?
Oh, sorry, that's Python. You're right. This would be dot push. Thank you. All right, and then our function. Then after this loop finishes, we return the output array. All right. Does this look like a sensible solution to everybody?
Where do you have number defined? If sum equals number.
Oh, you are right. I did not do that. It's number. I should be doing numbers I. Excuse me. I was doing Python in my head when I could do for number in numbers.
Should it just be I?
I, in this case, will refer to the index number.
Uh-huh.
And we don't want to push the index number to the array. We want to push the value stored at that index number.
Are they different?
Yes, they are. So if we're going through this array right here, 0, 1, 2, 3, 4, 5, 6, 7. Oh. Well, in this particular case, they would be the same. But we don't know that that'll be the case for everything, because I could easily pass in an array that's out of order or not including numbers even.
I thought we were just passing it a number and we're returning all Armstrong numbers that are less than that.
So if we look at our README, okay, it says write a program in Python and JavaScript to find all Armstrong numbers in the range of 0 to 99. The way our tests were set up, thanks to these console.logs we got, we've kind of created so that it's expecting an array of numbers. Because that's what I saw in the console.logs. But you're right, the README does say to just do it for in the range of 0 and 99. So
I understand what you're saying though. If you're expecting an array, they may not be in order or something. So that makes sense.
So you're right. There is a discrepancy here between my tests and what it says in the README. So in this particular case, I've written a function that can solve the problem, but will also solve other problems, which is not what was said in the README. You're right about that. And that may be something we want to address in the next iteration of this thing. Of we want to make sure that we're being clear about what we want in the README versus what we want in the spec file. So I'm going to run my tests here. So I'm going to say npm run test. And it says right here that I've passed all 4 of my tests. All right. So we found a working solution. It says right here, we also have release 1. Can we make this any more scalable and reusable later? So I think maybe that's kind of what I was thinking right here is the refactor, because it's the difference between doing one that automatically calculates 0 through 99 versus one that'll calculate everything in an array. But while we're here and talking about refactoring, did anyone have a solution that they think is more elegant or anything, or just had a different approach?
Our group, had a little bit of a different approach to the, I guess, the second for loop. The beginning for loop was pretty much the same, but the second, instead, we did a while loop, or a while loop instead of the for loop. And it was like a method that we had found like online to go through each digit. It looks more algebra intensive, I guess. It works with modulos and some division, but it seemed easier, less conversions, just to get each digit going forward rather than doing the for loop. That's a very bad explanation, but that was kind of our approach to it.
Well, I can find your pull request if you'd like to go through it with us.
Oh, sure, yeah.
All right, so is this one yours?
Yes. Which now I'm looking at how it comes up, and that wasn't a very good description.
All right, so we have our for loop. And we say something so const power equals ni dot to string dot length. So you're combining that into one thing. Cool. And then you have count, which equals ni. So which number we're at. Let me say while count is greater than 0. Well, how about you explain it to us now, Jarrell?
Sure. So while the number, whatever the particular number is greater than 0, we did like a let digit equals count modulo 10. So what that ended up doing was, like, say the number is 10, doing the modulo count modulo 10 or 10 modulo 10 will end up giving 0 first. So it'll be 0 to the power of 2. So it'll still come out 0. Then we'll take 10, divide it by 10, which is 1. And then I had to add in the math.floor to make sure that whatever number was, it would floor down to the lowest integer. So I guess like if it was like 3.33 or something, it'll go to 3. But so for this example, 10 divided by 10 equals to 1. So then that would equal the new count now. So now count is still greater than 0, or 1 is greater than 0. 1 modulo 10, which just comes out to 1. And then 1 to the power of 2 would still be 1. But then once the 1 is divided by 10 at the count, it would equal whatever it would normally equal. I don't know, it'd probably be like a bunch of digits or a point, whatever. But that's what the floor does, and then to bring it to 0 to end that while loop.
All right, yeah, I can see what you're doing there. It's definitely one of the solutions that I never would have come up with because it is much more mathematical than my usual approach to things. But I can kind of see what I can kind of see what you did, and I think I can't say for sure if one is more efficient than the other because I think they both have their merits. So well done.
Oh, and the absolute only reason I found that solution was because originally I'd done it the way that you had just done it right now with the 2 for loops. But I made a mistake with adding the sums up. I didn't have the let sum equal 0 in the right spot. It was outside of the for loop. So I kept getting like a weird addition, and I didn't know what I was doing wrong. So then I found this way to do the count. I put it in, got, of course, the same answer. It was still wrong. So I was like, all right, what am I doing wrong? And then once I saw the sum was outside of the loop, just moved it into the for loop, and then it was magic and everything just happened to work out.
Still, that's very well done. All right. What other questions do you have about Armstrong numbers?
I have a question. So with Jared, we did like almost the same, but on the like line 21, 22, 23, like we put like in one line. Yeah, you were declaring like variables, right? So I was like, I have a question about the variables. I mean, what is the preferable in coding area? Like, is it more preferred to do like all little like parts, or which one is more preferable?
Good question. So I prefer to always err on the side of defining more variables and being more explicit about what you're doing, because what my goal here is I want to make sure that I want to make this as clear as I possibly can to any other developer who would have to look at my solution and say, okay, what is she trying to do? There's nothing wrong with chaining methods together. It can be much more efficient in terms of like, length of your code and everything like that. So I wouldn't necessarily say that one is completely worse, but in general, I would prefer to break things up because I think it's makes it more easy. It makes it easier to read for other developers.
Is there a prevailing sort of preference in coding interviews? Like, is it impressive to use as few lines as possible and make it as complicated as possible, or is it appreciated to be very, very clear, or is it, could it be confusing that maybe you aren't as good at coding if you're being super methodical or something?
So I would say that it all depends on how communicative you are. So if you put many things in one line, if you include, say, a comment that explains specifically what that line is doing, then that'll also be fine, because then your interviewers can see, okay, that he's chaining a lot of methods together, but he's being very explicit about why he's doing that and what it does. And when it comes to whiteboarding, which we'll also get to, same thing. You can chain as many methods together as you want, but make sure you're saying out loud what it does, as opposed to putting a bunch of different methods together and saying, okay, this gives me 0, without saying, well, why? Why does it give you 0? So in coding interviews, always err on the side of being too verbose, whether that means breaking things up into multiple lines or just explicitly saying, here's what this does.
Yeah, just because you solve a problem in a single line doesn't mean it's the best way to do it.
Yeah.
So yeah, just be as Noah said, just be overly explicit into explicitly what you are doing.
Yeah. I'm sure you've all seen solutions on Code Wars of people who solved like a massive thing in exactly like one line, and it's like 5 different methods strung together, but they don't say what they do. Don't do that.
And no one's going to be impressed that you can do that. It's like they'll be like your interviewer will be impressed by your communication ability, communication skills.
Competitive programming looks silly.
All right. Any other questions about Armstrong numbers before we move on?
On the initial array that we were inputting, like taking in as a parameter, we used a for each instead of like a for loop. Is there ever going to be a point where like that makes a difference as far as performance, or like what we care as long as it works, I guess?
I don't believe that there's a significant difference between a for loop and a for each loop in terms of performance. Don't quote me on that because I've never compared myself, but I don't see a reason off the top of my head why that would make a difference.
Cool, thank you.